All right, it is time. Welcome, everyone. It's good to see you again. I hope you're doing well and you have enjoyed your weekend, right? The last class, we learned how to calculate the simple probability. Remember the simple probability that's supposed to be the division between some quantity number events divided by the total number of events. And also, we learn how to calculate the prediction of some kind of people they're supposed to like some kind of brand of food or television program, something like that. Remember this prediction that's supposed to be equal the P% of the probability multiplying by the entire population or central or in one specific way, one specific activity. Just a part of this lesson with the students, we're going to learn the two kind of counting principles. One of them is the permutation, and another one will be the combination. Okay, what will be the difference between them? Well, the difference between the permutation combination in both cases that will be an arrangement of objects, but in the permutation. The order is crucial. Meanwhile, in the combination, it doesn't matter the order. So if you see, for an example, we have a 6 permutation of the letters A, B, and C. How we can permute this situation? We can take like, for example, A, B, C. Another one could be A, C, B. Another one could be B, A, C or back. But this is not for back of chromatic. This is only a coincidence. B, A, C. Another one will be B, C, A, C, A, B, and C, B, A. Just like if we have again a plane of letters and you want to prepare an arrangement with 6 permutation. If you can count this one, there's gonna be 6 permutation. These counting principles, my dear students, is we call a permutation, arrangement on it of objects that we're supposed to prioritize the order. Okay, and this combination, if you really want to do it in a numbers, because we have a three-thing combination, this is the recursive multiplication or recursive product. What does that mean? Every time they going to permutate, we have to count them for numbers, one onto the number we're supposed to permute. For example, in this situation, because we're looking for 6 permutation, in decreased order, we can multiply the numbers since the number 3 onto the number 1. I mean 3, 2, 1, 3 times 2 times 1, that will be 6. Or if you wish, we can arrange this permutation in increasing order. I mean, on 1 until 3. 1, 2 times 2 times 3, and the result will be 6. Why is that possible? Remember that community property, the order of the factors doesn't affect the final result. A permutation is the art of counting by means of the recursive multiplication. It could be written in decreasing order or increased order. In this situation, as soon as you can see in the whiteboard, the expression can be greeted like number 3, an exclamation symbol. This exclamation symbol, my dear students, we can call this one like a factorial. 3 factorial. What does that mean? 3 factorial means the product between the number 1 onto the number 3, or if you wish, the product of the number 3 onto the number 1. For that reason, according to the situation, we have the postulate for the factorial numbers. For any possible integer, the product of the integer for one n is called n factorial, and it's written like an n exclamation symbol. And it could be n times n minus 1 times n minus 2 and so on. And simply worse, if I said find the 7 factorial, you can read this product in increase or decreasing order. For example, if you want to write this product 7 factorial in decreasing order, we're going to say 7 times 6 times 5 times 4 times 3 times 2 times 1. Right? This is a one singular way we can write the 7 factorial in decreasing order. Or if you wish, we can write the 7 factorial in increasing order. I mean, multiply the numbers 1 onto 7. I mean, 1 times 2 times 3 times 4 times 5 times 6 onto times 7. It doesn't matter. You can use in decreasing or decreasing order. At the end, the result will be the same. This is what does that mean, the postulate of the factorials. Well, but there is a one singular definition because if you ask me, Mr., what happens if we have negative numbers? Well, to tell you the truth, the principle mentioned only with positive integers. That means there's not going to be negative numbers because we're talking about everything that we're going to interacting in the real life situation. For example, a number of posters, soccer, football balls, for example, markers, or any quantity we're going to manipulate in real life situations. In that case, there is no negative numbers. But how about if you say, what happens we have a quantity of zero? For example, if I have 5 apples and I ate them, I have 0 apples. What happens if I try to locate the factorial for number zero? Well, the zero factorial, because it's a counting principle. Remember now, counting principle, we're going to start from counting until the number one, until infinite, right? Nobody wants to count like a 0, 1, 2, 3, 4, 5, 6. But just in case we have a quantity like a zero factorial, this zero factorial by definition, or for definition, then we're going to be 1. This only for definition. Why? Because at the moment, we're going to start counting principles to count any numbers, quantities, something like that. Everybody start from the number one. This is what does that means, this factorial principles. And if you really want to calculate what will be the order of permutations, remember the order is high priority in the permutations. These order permutations of n objects taking R at the same time can be written like an NP, well, NPR, actually, not PC. Let me fix this one. Like a NPR, NPR. This is NPR with the letter N that will be represented by the quantity of numbers, the total quantity of numbers in the permutation, and the letter R represents the numbers you're going to take the permutation. And simple merely words, the mass of this situation, my dear student, that the letter N, always, 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 because both are numbers, but the letter N always will be greater or could be equal. Sorry, the letter N could be greater or equal than the letter R. These numbers. The letter R never gonna be greater than the letter N because we're going to working with positive numbers. So in the way we can write this expression like an NPR that will be given by N factorial over N minus R factorial. Okay, this is going to be the formula we can write this situation. Questions on this part? Or everything is clear in the concept of factorial? For example, if I said estimate 5 factorial, I'm not using this formula, not yet, but just I'm going to explain to you how we can write 5 factorial. 5 factorial could be written like a increase or decrease orders as you wish. For example, that means I'm going to multiply the numbers since the number 1 until the number 5. Or if you wish, 5, 4, 3, 2, and 1. It doesn't matter what kind of number we're going to use. At the end, the result will be the same. So in this situation will be 120. This is going to be the final result. And this is what I was explaining, or at the moment going to use the factorial concept. Yeah, don't worry, Rosie, you understand. So in that situation, we have 3 examples. If we need this develop a couple more, don't worry about it. We can do it also. At the end, if we have some the N and R we have the same quantity. For example, if I have both, that will be 3p3 for this, just to give you a note. Remember, 3 minus 3, that will be 0. 0 factorial, by definition, that will be 1. Okay? And this is only the formula that we need to got in the permutations. Okay? For example, we have 3 examples. And the first example says, you have 4 posters to hang in your room. You want to put 1 poster of each wall. Okay? So the question is, how many ways can you arrange these posters? This interesting situation. What will be the first thing that we have to do? Well, identify what will be the values of n and what will be the values of r. Well, the letter n, that's supposed to be always greater than equal than r, right? So I have a question for you. According for the problem, how many posters we supposed to have? According to the word problem, how many
Four
posters?
posters.
4 posters, right? So we're going to write, and that will be equals 4, right? And if we continue reading the problem, says you have 4 posters to hang in your room. You want to put 1 poster of each wall. 1 poster for each one, for each wall, sorry. The question is, what will be then the value from R? What could be the value from R? Will be 1 or
One.
will be 4?
Uh,
Read the problem carefully. You want to put 1 poster of each wall. That means if you had 4, you really want to have a total of 4 posters, you're supposed to hang in 1 of each wall. That means in your room, how many walls do you have in your room?
4.
4, right? For that reason, the R value also will be equal 4, because we have 4 posters. You really want to hang 1 of each wall. And think about it. Your room, how many walls do we have? It's 4 walls, right? For that reason, the letter R will be 4. For that reason, the question is, how many ways can you arrange these posters? For that situation, that means we have to looking for the permutation 4, 4. Why 4, 4? Remember, we can write NPR, and because N and R have the same value, okay, excellent. Because they have the same value, we can write this situation over here, okay? Now what we're going to do is going to apply the problem, the formula, permutation 4 and 4, okay? The problem says n factorial, that means 4 factorial over 4 minus 4 factorial. This is the way we're supposed to write the formula, okay? And remember the concept of factorial. The concept of factorial is what we call the recursive product between their numbers. It could be written in increasing or decreasing order, as you wish. Well, if you wish, we can manage like an increasing order, but once again, it doesn't matter the order, the result at the end will be the same. For that reason, 4 factorial is the product between the number 1 until 4. 1, 2, 3, and 4. Okay? How about in the denominator? In the denominator, we have to remember, we have to solving, as a matter of speaking, the operations inside the parentheses. 4 minus 4, that will be 0. And we got 0 factorial. And 0 factorial, by definition, that will be 1. For that reason, my dear students, the answer will be simple. We have to multiply 1 times 2 times 3 times 4. And the answer will be 1 times 2 times
24.
24. Exactly. So the question is, how many ways can you arrange the posters? Well, simple, 24 ways. 24 ways. And that's it. Understood why the letter R in this situation is 4? Understood?
Because there are four walls.
Exactly. That's why. And your every room has 4 walls. I don't know any rooms who has only 2 or 3 walls, right? We have 4 walls. Got it? Okay. Let's analyze the second problem. In the second problem, mentioned judges at the science fairs are awarding prizes to the first, second, and third place finishers. Okay. The science fair has 10 contestants. It has the 10 contestants. Question is, how many different ways can the first, second, and third place prizes can be awarded? Okay, obviously they're asking for the permutation in that situation. So what we have to do, the first thing that we have to do once again is identify what will be the values and our values. Remember, and could be equal or greater than r. Never, never, never r will be greater than n because always we're going to working with positive numbers. So guys, what could be the letter n? Read the problem carefully and analyze the answer. Once again, judge at the science fair are awarding prizes to the first, second, and third place finishers. The science fair has 10 contestants. Question, how many different ways can the first, second, and third place prizes can be awarded? What could be the letter N?
10.
Exactly, because we have the total number of contestants. Okay, excellent. The letter N will be 10. Perfect. And the R value will be, what do you think?
3.
Exactly. Why 3?
Because they are going to give only prizes to the first three places.
Excellent answer. That's why the letter N, R will be 3 because only going to have only 3 prizes. For that reason, they're probably asking for, let's try to find out the permutation of then 3. This is the problem what they're asking for. Remember the way we're supposed to write this initiation, remember the letter N, that both are sub indices, right? But the letter N that will be located outside and the letter R will be inside, okay? So what we have to do? Well, let's try to apply the formula. Permutation 10(3) equals 10 factorial over parentheses 10 minus 3 factorial. Okay, this is the way where we're supposed to write this formula. Continue with this situation. Remember, 10 factorial could be the product between 1 to 10 or the product between 10 to 1, increasing or decreasing order. At the end, the result that will be the same. But before to do that, I'm going to write the concept 10 factorial over 7 factorial. Why? Because 10 minus 3, that will be 7. So at the moment, I'm going to solve this problem. Doesn't explain you ready. Increasing or decreasing order. It doesn't matter, that will be the situation. That will be 1 times 2 times 3, 4, 5, 6, 7, 8, 9, 10. That's the meaning 10 factorial. We can write once again 1 all till 10, or if you wish, we can rewrite this especially decreasing order. I mean 10 all till 1. And how about with the number 7? Same situation, 1 until 7. 1, 2, 3, 4, 5, 6, 7. Okay, because we have a product and at the same time division, if you see, we can perfectly cancel the numbers, the product of the numbers 1 until 7. 1 until 7. And what will be our result? The permutation 10, 3 will be given by the product of the numbers 8, 9, and 10, right? So what will be the answer? 8 times 9, 72. 72 times 10, that will be
720 ways.
exactly 720 ways. This is going to be the answer of the problem number 2. Of the problem number 2. This is a simple way how we can identify the situation. It's simple, right?
Mr. What does N and R exactly mean?
Excuse me?
What does the N and R exactly
Ah,
mean?
the letter N represents the total quantity of object that we're going to have a situation, a random objects. And the letter A, the letter R represents the quantity of objects that we're supposed to arrange in one singular period of time. That means in this situation, 10 contestants, 3 awards. How many ways we can deliver the prize? For example, if I started from the third place, after that second place, after that the fourth place, or I can start from second, after that the third, after that the one. This is the meaning of that situation. The letter N represents the total number of events, and the letter R, the quantity of the events that we're supposed to arrange. That means, understood?
Yes, Mr.
All right then. So let's solve the problem number 3. Let's going to see. A restaurant has 12 identical tables. 12 identical tables. One evening, the restaurant accepts reservation for 6 of the tables. The question is, how many choices does the restaurant have for seating the 6 groups? Okay, this is an arrangement also, right? Well, let's going to identify what will be the value and what will be the value from R. All right. What could be the value from N?
12.
12, exactly, because it's the total table that we're supposed to have. And what will be the value from R? The number of arrangement that this we're supposed to do? The number of reservations?
6.
Exactly, simple. 12 and 6. So in simple merely words, you're asking for the permutation 12, permutation 6. It's a way of probability in simple merely words. Okay? Now, what we have to do? Well, the same thing that we are performing in the rest of the problems. And let's going to solve this one applying the formula. So we got this situation will be 12 permutation 6 will be given by 12 factorial over 12 minus 6 factorial. Okay? I'm going to skip, because 12 minus 6, that will be 6. So let's going to continue solving the situation. Instead to write 12 factorial, we can write the product between the number 1 until the number 12. I mean, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or is this an increasing order? Or if you wish, we can write this expression like decreasing order. I mean 12, 11, 10, 9, and so on. It doesn't matter. Remember the community property, the order of the factors doesn't affect the final result. And divided by what? If we subtract 12 minus 6, that will be 6 factorial. And remember, 6 factorial, the product between the number of 1 and the 6. So 1, 2, 3, 4, 5, and 6. So what we have to do, we can cancel the numbers 1 all to 6, and this permutation will be the product between 7, 8, 9, 10, and so on. Okay? For that reason, I'm going to write over here 12 permutation 6, and I'm going to give you the answer. All right, so that will be 12. That will be 665,000. 65,280 choices. And that's it. That's all that we have to do in the problem number 3. What was the process that I made? Well, only multiply 7 times 8 times 9 times 10 times 11 times 12. And that's all that we have to do. Let me know when you're finished to copy that one. I don't know if may I erase the left side of the whiteboard or not yet. Mhm. Hey, take a picture, by the way. ¿Puedo borrar esta columna de la pizarra? ¿O todavía no, muchachos?
Mister.
¿Puedo borrar esta columna?
Sí, mister.
Ok, bueno, voy borrando esta columna. Esa por mientras la voy dejando aquí. Now I'm going to copy the concept of combinations. Mhm. And you shall see this concept in this not so complicated thing. Mhm. What is the definition of combinations? Okay, we're going to define like a combination is a selection, is a selection of objects, of objects. Okay, it's a selection of objects where the order in which the objects mhm, in which the orders are chosen is not important. Is not important. This is the definition of the combinations. And what will be the postulate of the combinations? Well, to find the number of combinations, to find the number of combinations, to find the order of combinations of any objects taken, taken R at a time, taking R at a time, at a time, comma, divide the numbers of permutations, divide the number of permutations, the number of permutations of n objects taken are at a time by R factorial. Okay, and simple merely words. What will be the formula? Instead to use the permutation, we're going to say n combinations are, that will be equal n permutation r, n permutation r divided by r factorial. This is what the postulate says. But if you don't want to use this singular formula, well, we can use that situation. Like for example, NCR will be given by, well, we can calculate use n factorial. And now I'm going to include r factorial minus n minus r factorial. Both formulas will be the same. I don't know if you can see the difference. If we were want to choose the second one, the difference between the second one, the combination versus the permutation. Well, the difference between them in the denominator, we have to multiply r factorial. In the combinations, we multiply by n minus r factorial. In the permutation only, we're supposed to divide n factorial over n minus r factorial. This is going to be This is going to be the difference between their formula. Or if you wish, you can calculate first the permutation and after that divided by r factorial. Both formulas are the same, but what will be the difference between them? If we choose, if we really want to use the second one, we're going to obtain the answer at once. This is going to be the difference between them. Okay, so I'm going to give you an example. In the example number one, in this situation we have, you want to buy 4 different CDs. You want to buy four different, 4 different CDs. CDs, okay? Period. You can afford to buy, you can afford you can afford to buy, you can afford to buy only 3 of them. Only 3 of them. Okay. So the question is, how many combinations of CDs, how many combinations of CDs can you buy? Okay. So as soon as you can see this time, the problem asking for what will be the quantity of combinations of CDs that we have to do it. Well, in this formula, from the combinations, just like in the permutation, my dear students, the letter N always at the same time over here, that could be greater than equal than the letter R, because we are going to working only with positive numbers. For that reason, what we have to do, we have to identify what will be the value from N and the values from R. Would you like to tell me what could be the values from N?
4.
Exactly 4, because it's the quantity of CDs that's supposed to be in the store, right? And how many CDs you can afford?
3.
3. For that reason, the letter R will be 3. Now, what are we going to do? Let's find out the combination. Both formulas are the same. In the first one, you have to calculate the permutation after that divided by the R factorial. In the second one, we can replace all of them at once. My advice, you can use the second formula if you really want to take a shortcut. That's them tell you the truth. So that reason, 4 combination 3 will be given by n factorial. Remember, will be 4 factorial divided by 3 factorial multiplied by 4 minus 3 factorial. This is the way we can establish this formula. So 4 combination 3. Remember, 4 factorial is the product between 1 until 4 or 4 until 1, depending the order you're going to use in this situation. Increasing or decreasing order, it doesn't matter. 1, 2, 3, 4. All right. R factorial, the product between 1 until 3. Well, 1, 2, and 3. And you know, 4 minus 3 will be 1, and 1 factorial obviously will be 1. So because we are talking about the product, we can perfectly cancel the product between until 3, 1 until 3. So the answer will be 4 combinations. Tomorrow, if God wills, we're going to continue solving. Okay. We can solving like how to say that, solving more problems than one. Okay. I don't know if you have some doubts or questions into this one, or everything is clear.
Everything is clear, mister.
All right then. Do we have some time yet, or it is time?
No,
It is time.
8. Yes.
All right then. Okay, guys. Thank you so much for the attendance. Have a great and wonderful day. And if God wills, tomorrow we're going to continue with solving another examples. Okay, for this combinations and permutations. All right. Well,
Bye,
if there are no
Mister.
My
questions, you're
mister,
dismissed.
my mister.
You're dismissed. Bye bye. Mhm.